of shared area where two different segments of your browser could communicate. For example, this global state that you saw. All right, so that was the concept. Now, how do we make this easy to program for? We chose Java as a language to first extend this in. We call it RibbonJ. All right, so we wanted to be backwards compatible, make it as easy as possible for existing programs to work on this. We wanted to make heaps first-class objects, so we didn't want some new type of concept in the system, just reuse the existing class and object ideas. We also want to provide, leverage the type system to model these sort of patterns or types of protection domains that we saw in our example. And we also want to be able to provide enough structure to enhance, static analyses, for example, alias analyses, given this particular object and these two threads, which exactly, which variables could actually point to the same object in the heap. Are they alias to each other? So first we expose this protection domain idea with this new keyword, which is used at the same level as a class declaration. So you're defining a new type. It's a protection domain type. All right, it accepts arguments which model which domains this one is going to interact with. And then inside of it has a list of rules. Okay, how do I grant privileges, or how do I acquire privileges, or in the language it's called require privileges from other domains. All right, so just a reminder, here's our example again, but I've colored the different protection domain types. I mean, it's pretty intuitive, but you've got your own type for the state, the shared state, the DOM, the scripts, and the shared plugin state. Each of those are modeled with its own type. Each type can have one or more instances created of that domain at runtime. All right, so here's what the code looks like. Pretty similar to class declaration. You start out with the protection domain keyword. This global shared domain accepts an argument. So the global shared state, it needed privileges from the private state, and it also needed to give privileges, allow the private state to have read, write, and inject access on it. So the way that this is modeled is through these grant and require statements, and it's pretty intuitive. You just say, grant or require, the set of permissions, and then the named argument defined in the protection domain line, which domain that you're referring to. And so these are sort of templates. How do I structure this protection domain statically, and then at runtime these things are instantiated just like objects, and the parameters are filled in so the connections are actually made to these other types at runtime. So continuing the example, the global shared state also required the Flash plugin global state. It needed to give read, write, and inject privileges to and from. So when we model the plugin global state, because it's created presumably after the browser global state, so back in the definition here of the global shared domain, the plugin domain didn't yet exist at this point in the program. So that's why we couldn't reference that plugin domain yet here in this declaration. But instead, we just grant privileges. Once the domain is created, then it says, okay, grant privileges to this browser shared state onto myself. And so this way, and that's why both grant and required in the require statement have to be in the language. All right, in the slightly more interesting case, you've got the DOM domain, which has layers both on top of it and below it. And you just see it that accepts two arguments, and we're essentially giving all privileges, these bidirectional privileges on all three types to each layer. All right, and then finally you've got very similar for creating up your script domain here. So how do we model ribbons in this language now? So ribbon is an extension of the thread group class. thread group, just like it says, it's a named collection of threads. You can stop, start, deal with the threads as a group, give them a name. And a ribbon also sort of acts as its own protection domain. So implicitly, it's got its sort of own little private area for it to work with. Any ribbon local data. And then similar to protection domains, it will accept a named argument list of protection domains that it's going to live within. And the first protection domain on this argument list is called the default domain. Any allocation that happens that's not annotated will be put onto this default domain. And then similar to this, to get the current object, you've got this ribbon to get the current ribbon context. Alright, and then we extend the new operator. So these ribbon objects essentially in protection domain objects, the protection domain objects represent the heaps as first class objects. The regular Java objects that happen to be associated with some area of your memory. And then the new operator can optionally accept a protection domain as an argument, so you know which protection domain you want to allocate within. Okay, so going back to this example here of ribbon creation, how would this look like in the code? So recall the definition, the declaration for this protection domain, the DOM domain, the document object model. So it accepted the global shared domain and the plugin global domain. So you can see here, it's tied to the browser global state, and it's also tied to the Flash global state. All right, and so then we model this ribbon. Just with the ribbon keyword, we're declaring the new type. It accepts one argument because you can see here that it's only living within one protection domain. It's living within one protection domain for this document object model. So it only has one argument. All right. This particular tab might have a list of scripts that it's associated with, and then say that we wanted to start as Flash script. So what would we do? First, we'd create a new protection domain at runtime with this particular type, and we'd connect it to the ourself, so the DOM for the document object model domain, and then the document object model domain is also associated already with this browser, with this Flash global domain state. And those arguments, notice, are exposed as fields, so that we can just use the instance of that protection domain DOM .p, which is referring to that the argument of the protection domain. All right, and then here we just create the ribbon object like normal, but notice we've got this new where keyword here. So the where keyword essentially just instantiates the ribbon argument list with the concrete set of variables, protection domains, that it's going to live within. In this case, the script ribbon just lives within one domain, which is the new domain we just created for it. And just to show you the syntax, I've showed you here how you could specify which protection domain you want to allocate within by putting in angle brackets after the new keyword, some protection domain object. In this case, that doesn't actually do anything different because the DOM protection domain is the first protection domain of this DOM ribbon here. So had we not specified that explicitly, it would have taken that first argument on this ribbon as the ribbon to use for allocation anyways. All right, and then we just treat these ribbon objects like normal, so now we can add it to our list of script ribbons, and then we can actually start the new point of execution, the new thread that's going to live inside of this new ribbon to run the Flash script and put it into the thread group of this ribbon. All right. So now let's move on to how do we actually implement this. Right now we only have it implemented inside of user space, so it's obviously only secure for a managed language where all the native code is fully trusted, and we're currently working on a kernel extension. So here's an overview of how we implemented this inside of user space. We're using regular operating system